I'm Evgeny. Thank you everyone for coming today. I'm co-founder of Fluence, and I'm gonna tell you about the open application infrastructure or open application platform that we're building at Fluence, why it's important and how it works. And then we're gonna have another talk from my co-founder Dmitry about the technical fundamentals of the peer-to-peer coordination and composition language, programming language that we created for creating peer-to-peer applications and distributed systems. So don't miss it, it will be in the next hour. So probably I would start from the term deplatforming, which got really popular in the latest year. And it's sort of like if you think of concerns of the existing web and existing state of technology in the internet, there's a lot of concerns about different sorts of censorships, like deplatforming from consumer social networks, or dependency on some web APIs that other people control. Like if I build an application and rely on some data provided by third party, what happens to my application if this third party disables access to this information? And the same dependency sort of we have in the cloud stack, where we built on proprietary SDKs and tooling. And the more we do it, the more proprietary it becomes. So like it's basically the cloud stack over years, switching from open source to closed source proprietary. And when we got deplatformed, for example, as a parlay recently from AWS, how hard it is for us to switch to another cloud. It requires a lot of resources. And same things about scalability stuff. Like if you think we have more and more applications, more users, everything gets more complicated quickly, and it's getting harder and harder to maintain complex distributed systems. And they obviously fail, and failures are more and more painful. So something needs to be done. And there is a movement called Web3 or Decentralized Web, where people trying to create new projects, network protocols that intended to solve these issues and to rethink how we create applications, how we create user data storage, how we scale applications, how we can avoid censorship and do it all open source in a more transparent way. Many of them are blockchain related, some of them are not blockchain related. So like different approaches here. And I'll speak about our approach, what we do at Fluence. We call Fluence Open Application Platform. And basically what we do, we create the peer-to-peer software development stack. So using our software development stack, our tooling, you can create peer-to-peer applications and distributed systems. And essentially you can create an app where your users just work with each other directly, talk to each other directly without any specific server where their data kept. So their data either travels through the network from one end to another, or being provided from some servers, but they are there can be several services that replicate data or replicate business logic somehow. So you're building on this stack and not on some proprietary specific cloud SDKs. So you can avoid even DNS system if you building on peer-to-peer development stack. And we also create hosting marketplace. It means that if I'm a provider of some hardware, some data center, I own some data center, or I own some just a spare computing hardware, I can be a hosting provider for some applications, for backends of the applications, and earn money of it. And so there's a decentralized blockchain-based marketplace where I can register and provide services for developers who create peer-to-peer applications on the stack. And there is a monetization model that allows not only compute providers to monetize their hardware, but to developers of something useful to monetize their software components if they're being used by other applications on the platform. And I'll tell about it later. And so first is peer-to-peer stack. What is that? We like at the core of our peer-to-peer stack is Aquamarine. It's the programming language that we created to design peer-to-peer applications and distributed systems easily and like much more easy than you can do it right now. This is sort of syntax sugar on top of distributed systems composition and distributed services composition. And imagine that when you in the proprietary, like in traditional cloud stack, you have microservices and you have Amazon Lambda. And when you write a Lambda function, usually what you do is you write the code that gets some data from one microservice and puts data to another microservice, or gets some data from user request and calls some microservices to execute logic. Aquamarine is similar, but with the main difference that it's not executed at some central gateway. It basically the peer-to-peer, like executed by the whole network. So if you need to execute some business logic that requires calling some endpoint on first service and then some endpoint on another service and then calling some other services in parallel and then put some data in database and return some result in a browser to some other user. So it will be executed step by step, service by service, and the script itself will be packaged with the request, with a data packet that travels from initial peer, from service to service, from peer to peer, from relay to relay, in order to execute your business logic that you created. So it's sort of programmable requests instead of simple request response model. And this is super useful to create all kinds of distributed system. It's based on the theory on PyCalculus theory, and you can design all kinds of distributed coordination using the language. And I'll show you an example. And the other important thing is services that are very similar to microservices. So we call services the sort of API, the things that it exposed to the network. So, and they are compared to traditional microservice approach. They are WebAssembly based, so they are fast, light, and well sandboxed. They are easily composable with the WebAssembly standards. We use interface types. There can be anything like the same that you can think of microservices, but usually lighter. So they can be stateful, they can contain state, they can be completely stateless. They can access some external API, so executable or your legacy microservice in order to bring some data. So they're totally like a pluggable and easy. And the way how you use this peer-to-peer stack is you write code on Aquamarine that operates some business logic on top of services. So on the left, you can see the lower level implementation of the Aquamarine called AIR, intermediary representation. And it's Lisp style a little bit complex. So for that, like to make it really useful, we have high level implementation, which Dmitry today will have the whole talk about. So it's programming language that you write the network composition, and you can write a lot of stuff with that. You can like on the language level, on the operations level, you basically have ways to discover other peers in the network, connect to them, call endpoints on these remote peers, deploy services to some remote peers, and do all kinds of parallel execution, error handling, like even loops. So you can do whatever you want in terms of distributed execution, and you also have authentication. You might have like specific authorization to your application services. So your application that you would run on this stack would be secure from unauthorized access. And second thing is what we bring is with this stack is the hosting marketplace. So if you use this peer-to-peer development stack to create application, you can host it by yourself. So you can run nodes that support Fluence stack and run services the same way as you run microservices in the backend and be happy with that. But if you want to use Fluence as a cloud, you can rely on other people running nodes for you. So it might be more professional and trusted companies and people. It might be less trusted people. You have free choice, whoever you choose to provide you hosting capabilities. And it might be even Amazon that's running Fluence nodes and support Fluence stack. So you can rent hardware from them, for example, if they are on the network. And so it's the marketplace economics sits on blockchain. So it's totally decentralized. There is no entry barriers. It's powered by crypto coins. So there is no credit card, KYC, or whatever complexity that might be concerned for some countries. And the important thing here is that you build on the open Fluence stack. So it's really easy if you're not happy with some host, you can really easily switch to other hosts compared to proprietary clouds where like switching from Amazon to Azure is painful. So you can use this marketplace as the cloud, and it can build you can deploy services to nodes in the network. And third important thing is monetization. The stack that we are building brings the new business model to developers that haven't really existed before. So the idea is that right now you like usually how you do applications, you create an app, you pay, like you deploy to some cloud, like backend to some cloud, you deploy some front end to some application marketplace or on the web, and then you cover the cost for the cloud. Like if you have more users, more user data, then you pay more money for the backend hosting, and you have to extract value from it, because like you have to you have to be sure that you can cover the cost of the hosting. Just one second. I'm just want to check that everyone hears me fine. So, and because we have the new peer-to-peer application development stack and we have the hosting marketplace, we can bring the new business model where we decouple all application ownership from authorship. So if I created an app, it doesn't mean that I have to run the app. And the app can be run as a set of services, can be run by nodes in the network. So basically that's it. Developers can create applications, can publish it to the hosting marketplace, and distribute it to users. And when users, like if it's the paid application, so when users decide to install it and use it, they would be able to choose and pay to host directly, to host backend for them. And developers will not have this costs of hosting backend, but they will be able to share the revenue of hosting providers. So they will get effectively they will get royalty from hosting revenue. And this is a little bit different. As I said, this is a little bit different model of application creation than we used to. We used to create the extractive model when we host everything by ourselves, attract users, and then extract value. And here we motivate developers to create something useful. So if you created something useful and people use it, or people create something like some other applications on top of it, then you can benefit from it. And this is the intention to build, by reversing the incentives, we can build the open runtime, or like collaborative runtime for applications, and collaborative cloud that would share the revenues with the authors of useful components. And so the way how it would work, if I'm a developer and I sort of creating this open application, for example, open Telegram, open Messenger application, it means that I do not control the hosting, the storage, and the execution of the backend, and it's controlled by some set of hosting providers. And so I have this sort of power balance. I cannot just create the new version of the application that deprecates some features that users like, or break some compatibility with some other products, because I have to convince hosting providers to update it, to update to a new version and provide this new version to the user base. And I do not have access directly to the user base because hosting providers talk to users and I only talk to them. And this way, I cannot just disable access from some web API, as happens in the centralized world every day. So, for example, I created the new version and some hosting providers updated, by the majority not updated. So like a lot of users still use the previous version of my application. And this might be important because we have a lot of examples of SaaS applications that you do not control. You just rent the access to them, and you have no ability to roll out a previous version if you liked it. And so technically, applications on the backend are still a set of services, and the applications themselves, if you think of this, like if you have different services, different available services on different nodes, what applications is? Application is some sort of user experience on top of composition of the services. So if there are different services created by different applications in the network, run by different nodes, by hosting providers, then there should be ability to package them differently and create different apps and give them to users. But they all can rely on all the same services under the hood, which is super cool. And these services can just be composed using our peer-to-peer stack. And in terms of creating value and like in terms of new business model, it becomes super attractive to create something like some useful component that other people will reuse and other people will use as a part of their applications. So imagine that I created some white label chat service, and I created and packaged it as a messenger app and got some users. But then, because we all living in the same, like we're using all the same peer-to-peer open source stack, other developers came and created, they created new services to implement stories or to implement stickers, and then they packaged them as the new applications and promoted to totally new user bases that they have access to. And they used my service as a part of their application. So my service still sits on some nodes in the network and provides like basic chat capabilities. And it means that my service got more users, get more usage than it had when I was alone, because like other people building on it. And then other like new developers came and created new applications from this Telegram or Instagram applications. Well, basically compose services on the backend. So they created new services, implemented new features, accessed new audience, and all of us got new users because they also like reuse the services that we created before them and that they use. And for them, it's beneficial because it's easier to build application. If you have in the network already a chat service, a group chat service, a comment service, the storage service, you can compose them using Aquamarine, using peer-to-peer stack into new user experience and new application. It's become faster and faster to create new apps. So a couple of examples of this. So if you think of what you can build using this stack, it's obviously peer-to-peer applications, as I spoken. So all kinds of chats, online collaboration, real-time collaboration, gaming stuff, where usually you have some backend bottlenecks. You can now do really in a scalable fashion with less involvement of centralized backends. You can apply this stack to traditional distributed backends, traditional microservice backends. You can use Fluence stack to compose, like to orchestrate your microservice swarm, to write some business logic to better manage your backend. You can create some rocket science stuff, like you can implement networking algorithms, like a Raft consensus, BFT consensus, like DMD, all kinds of peer-to-peer network algorithms, and then to make it easier for other people to build on top of it. And some blockchain related example is you can run applications by community. So imagine that you have the app that wants to avoid centralized ownership. And as a creator of the app, I would be happy to pass to the community hosting of backend of this app. So I would design the app this way that I would have several instances of backend service, and I would host it on Fluence hosting marketplace to allow my community members to run backends for the app. But because I would design like redundancy and replication, it can be done in different ways. But if I design it properly, then this app can run like fully on the community nodes, and even if some node goes down, other nodes are live, so they can serve users. And I can balance this with some blockchain incentive, with coins, with DAO, and so on. But just to give you some perspective. And we have some examples of applications that can be created on this stack. This is the FluentPad is the analogy to CoderPad online code collaboration tool. This is peer-to-peer application that allows you to write code in real time. We use CoderPad for developer interviews, for example. So this is the analogy of it. You can check out the repo and see how it works. And yeah, also like we have even the developer dashboard, like even the network dashboard that we have with a list of available services in the network and nodes that run in the network is also the app that built as a peer-to-peer. It has no backend at all. All the data it shows here, it gathers in the network by asking existing nodes what services they provide. So it's pretty cool to see how it works under the hood. So check out our website at Fluence Network. Take a look at this network dashboard as a sample application on a peer-to-peer stack. And I think, so that's all from me. And I invite you to join the Dmitri's talk about like a very detailed talk about Aquamarine, about how it works under the hood and our like its fundamentals. It happens in 30 minutes next hour. So if anyone has any questions, I'm happy to answer. Or that's it.
Thank you. That was really interesting. We can answer this Q&A here. I think we have time for another half an hour for the other speaker, right? So we can answer questions.
Yeah. Also, I mean, feel free to reach out to us in any channels, in Telegram, Twitter, email, wherever it makes sense. Happy to answer questions there. Yeah. Okay. I think let's wrap up then if there's no questions, and see everyone in half an hour in the next talk.
Thank you. Thank you all for coming.